Hi, this is Dr. El-Omari, and welcome to the first session of the statics online statics review sessions. This session is about the resultant of a coplanar force system. In this session, I learn how to find a resultant of the force in 2D or coplanar force system. This means in 2D. Next session it will be about the non-coplanar force system. So a force is in many design situations we have to work with a component of a force, or we have to find a resultant of forces. So the first step is finding a component of a force. We find a component of forces on the major Cartesian axis here in the x and the y. So the fx component and fy component forces are also treated as vectors. That's why they have also to have what is the direction. The direction of the x-axis is represented by the unit vector I, and of the y-axis is represented by the unit by the vector j. So you have, if we need to write then the force in its Cartesian vector form, then we multiply, or we write that fx times I and fx times g, which represent the direction of the x and the y components. If we need to, for example, find a resultant of several forces, as in this case, we start first by resolving the force into their components. So F1 would be resolved into F1x and F1 of y. F2 would be resolved into F2 and F3 of y. Notice here that F2 of x is directed towards the negative side of the x-axis, and finally F3 also has to be broken into or resolved into F3x and F3y, which are directed on the negative axis of the x and y. To find a resultant, vector-wise, we add the forces, but we cannot add the forces as long as they share the same line of actions. That's why we have to work with the components. So if we need to find the resultant, then we have first to add the x components, 1x and 2x and 3x, and add the y components together. Notice here that we use the negative sign that represent the negative direction of f2x, f3x, and f3y. Finally, we add the x's together and the y's together, and then you get the resultant force in its Cartesian vector form, represented by frx and fry, and the I and g representing the direction of the force. The following is to find the magnitude of this resultant force. Using the frx and fry, we can use the Pythagorean theorem to find the resultant magnitude, and then the angle. This is a right angle triangle formed by frx and fry. Then we can use the tan information, tan inverse tan of the absolute value of fry and frx. We use the absolute value because we have to first decide or form the drawing, and we'll see this in the example, what direction in which quadrant that force is, and then find the resultant magnitude and angle. So let's do this in a numerical example. This system is composed of the three forces given. Each force is given by the magnitude and the direction. F1 is by the magnitude and the direction represented by an angle measured from the positive x-axis, 30 degrees, and the other two forces are given by the magnitude and the slope, and the slope is given a relation of 3, 4, 5 for F2 and 5, 12, 13 for F3. So the first step is to find the resultant. We have to resolve all forces into their components. So this is the first step, get the forces components. We start with F1. If we need to get the x component of F1, then the x is the adjacent to the angle 30, then we just use the cosine relation. So you have 250 times cosine 30 gets you the, and if you need to get the vertical component, then you use the sine relation because the vertical is the opposite to the angle. F2, if you look at the horizontal component is parallel to that 4, or if we set a relation 4 over 5 is equal f2x over f2, then we can just write that f2x is 300 multiplied by 4 over 5, and this will give you the x component. For the y component, we will use the 3 over 5 instead, and then you get the y component. Notice here that because the y component f2 would be directed towards the negative sign, then we give a negative sign to that. The same thing here for resolving this force into their components. So the x component of F3 would use the 5 over 13, and the y component would use the 12 over 13. Notice that both components are directed towards the negative sign. That's why we add the negative next to the answer. So we resolved all components, all forces into their components. The following is find the resultance components by adding the x components and the y components. So adding the x components, notice also again the negative sign. You get an answer that is positive, which means that this x component of the resultant is directed towards the positive x-axis. Following is getting the y components, and in that case adding all the y's, paying attention to the negative signs. So you get a negative answer, which means that the y should be directed towards the negative side of the y-axis. It is important to draw this triangle because it shows you where the angle is. So connecting the tail of frx to the tip of fry, this is the resultant force direction. Following is to find what is the magnitude. So using these two values, we can just find with a Pythagorean theorem and find that this is the resultant force. And then finally, what is the direction? And here comes why do we use the absolute, because we already, so you just draw the triangle with the direction. So I know that positive and I know that is negative, then I know this is the angle. This is the angle that you are looking for. So if this is the angle that we need to find, then we can use the tan, inverse tan, opposite over adjacent, and then find the angle is 39. In some questions, it will ask you to find what is the angle measured counterclockwise from the positive x-axis, which is means asking about this angle. So you can just simply subtract 360 minus the 39.6, and this will give you the final answer. So we have the magnitude, we have the direction, and this way we found the resultant force of that system. As a final note, please pay very good attention. This is where mistakes always happens. The sign, direction. If you do a mistake in any of these, then the whole answer would be wrong. You will get a wrong component, which means a wrong resultant, a wrong answer. Everything will be wrong. So pay very good attention when you add the components. The other thing also, using the correct sign angle relation. Another, if you switch those, use the cosine, the sine for the x and the cosine for the y, again the whole problem will be wrong. You will get a wrong resultant, you will get a wrong and angle. So you have to be careful with using the which angle that you work with, the sine or the cosine, with which component, which slope you work with, 3/5 or 4/5, with which component, and because any small mistakes will give you the whole mm, resultant force will be wrong, magnitude would be wrong, and also the angle would be wrong. So this wraps up the first session, finding a resultant of a coplanar or a 2D system. And next session, you will learn about how to find a resultant of a non-coplanar force system or in a 3D. Thank you, and see you next session.